all know the story, the iconic words, the grainy footage, a triumph of human ingenuity that defined a generation. But what if the story you know is only half the story? What if this incredible achievement was born not from peace, but from a secret war fought not with bullets, but with rockets? What if the astronauts carried with them a presidential speech announcing their tragic deaths, a speech that nearly had to be read? Why did one of the three heroes have to be completely forgotten? How did a simple ballpoint pen become the most important tool for their survival? And why, more than 50 years later, do questions about waving flags and missing stars still persist? The moon landing was a miracle, but miracles are built on a foundation of chaos, near-catastrophic failure, and secrets that have been hiding in plain sight. Stick around, because today we are unraveling the 7 strangest, most inexplicable, and utterly captivating mysteries of the Apollo 11 mission. You will never look at this historic event the same way again. But before we begin, be sure to like and subscribe to our channel to support our community. It might come as a surprise to you to learn that the true motivation for planning the Apollo 11 mission was warfare, specifically the Cold War. This was a conflict ongoing between America and the Soviet Union. A fierce space race was unfolding between these two nations. In 1957, the Soviet Union earned the distinction of launching the planet's first artificial satellite. Its name was Sputnik, and it became the first object made by humans to be positioned in Earth's orbit. The American government was stunned to see the Soviet Union had overtaken them. A few months after that, in 1958, America successfully launched its own satellite. But 3 years later, in 1961, America encountered another major setback. Soviet cosmonaut Yuri Gagarin becomes the first human to travel into space. Once again, the Soviets had pulled ahead of America. Merely a week following this event, the American President John F. Kennedy writes a memo to his Vice President on April 20th, 1961. He inquires, how can we overcome the Soviets? By placing a laboratory in space, or perhaps by a journey around the moon? Are our current programs operating around the clock? If they are not, then why aren't they? Are we committing our utmost effort? Is there another space initiative we can pursue that would yield swift, spectacular outcomes to progress in this competition? And when? He receives the reply a few days later because he promptly understands that the subsequent major objective will be to send people to the moon. On May 25th, 1961, in a renowned address, he pledges to the world that he will send humans to the moon before the conclusion of the decade. And furthermore, the humans sent to the moon would be returned safely to Earth.
Before this decade is out, of landing a man on the moon and returning him safely to the Earth.
To many people, this seemed like an incredible declaration. Consider the year, 1961. Smartphones did not exist. There was no internet. Not even GPS technology existed. Computers were so primitive, and in such a period, he is vowing to send people to the moon. To accomplish this, over the next 5 years, he allocates $7 to $9 billion in extra financing to the space initiative. The complete Space Administration begins working toward a single objective. A few months later, the testing phase is already underway. First, they test the rockets that will be used to escape Earth's gravity. Then the heat shields of the command modules are tested to determine how much heat they can withstand. The propulsion systems of the service modules. From 1963 to 1967, numerous tests are conducted, all of which are unmanned. This means no human beings are inside the rockets during these examinations. In February 1967, they schedule the first crewed test. That is, an examination where astronauts would actually be seated in the spacecraft and ascend. This mission is designated Apollo 1. However, during ground tests on January 27, 1967, a fire breaks out in their cabin and the 3 astronauts preparing for the flight perish. Following this tragic event, NASA does not quit. On the contrary, it proceeds with its subsequent tests, Apollo 4, Apollo 5, and Apollo 6. All these flights are unmanned. They are for testing purposes once again. In October 1968, the Apollo 7 mission is initiated. Once more, an endeavor is undertaken to send humans into space, and it proves successful. Merely 2 months later, in December 1968, the Apollo 8 mission is launched. In this flight, 3 astronauts are on board and sent toward the moon. 3 months after that, in March 1969, the Apollo 9 mission is launched. This mission involves testing the lunar module, that is, the section of the spacecraft that will actually touch down on the moon's surface. And 2 months later, in May 1969, comes the Apollo 10 mission. On this flight, the 3 astronauts are tasked with performing nearly every procedure for a rehearsal, everything that will be executed on the Apollo 11 mission, with the sole exception of landing on the moon. Now you can observe the rapid pace at which NASA was launching these missions consecutively. Every 2 to 3 months, a new flight is initiated, in which the subsequent component is evaluated. Evaluation of rockets, evaluation of the spacecraft, evaluation of traveling to the moon. And after all these evaluations, ultimately, on July 16, 1969, the Apollo 11 mission is launched.
Liftoff. We have liftoff.
3 astronauts were included in this flight: the 38-year-old commander, Neil Armstrong, who was leading this mission, the command module pilot, Michael Collins, and the lunar module pilot, Edwin Buzz Aldrin. These 3 names are now permanently etched into the pages of history. Neil Armstrong and Buzz Aldrin became immensely famous figures. Everyone is familiar with them today. But Michael Collins is not nearly as recognized. Why is that? There is a particularly intriguing reason behind this. I will explain it shortly. The spacecraft for the Apollo 11 mission consisted of 3 primary parts: the command module, the service module, and the lunar module. The first 2 are collectively referred to as the CSM, Command and Service Module. The plan was that the lunar module would separate and land on the moon, and for the return journey, the lunar module would reconnect to the CSM so that the astronauts could come back to Earth. To launch this entire spacecraft, a Saturn V rocket was utilized. Prior to the launch, 1 million gallons of kerosene, liquid oxygen, and liquid hydrogen were loaded into this rocket. The total weight of this entire rocket was 3 million kilograms. With its assistance, the spacecraft traveled and achieved Earth's orbit. It required less than 10 minutes to reach orbital altitude, and then they circled in Earth's orbit for approximately 1.5 revolutions. Subsequently, they received authorization from Mission Control. The Mission Control Center was located on Earth. They established communication and provided the go-ahead for the translunar injection maneuver.
Control, go. Telcom, go. Jinsei, go.
This is the process of moving from Earth's orbit into a trajectory toward the moon. To break free from Earth's orbit, a Saturn V rocket was employed. This was the rocket's 3rd and final stage. All these events transpired within a 5-hour window. Following this, the journey required several more days. The astronauts waited inside the capsule, at times eating, sometimes sleeping, and occasionally taking photographs. On July 19, 1969, after traveling nearly 400,000 kilometers, the Apollo 11 spacecraft entered the moon's orbit. At this juncture, it became necessary to separate into 2 vehicles. The command and service module parted from the lunar module. Michael Collins was occupying this section of the spacecraft, which had been nicknamed Columbia. Meanwhile, the lunar module was named Eagle. This was where Neil Armstrong and Buzz Aldrin were. The key objective was for the command and service module to stay in orbit around the moon. Only the lunar module would detach and descend to the lunar surface. This meant that only Neil Armstrong and Buzz Aldrin would have the opportunity to walk on the moon, while Michael Collins would not. This is the primary reason Michael Collins is not a universally recognized name. Even though he was a vital member of the Apollo 11 mission, he never set foot on the moon. However, despite this, Michael Collins' role in the mission was arguably the most critical. This is because later, the lunar module had to redock with the CSM. And were it not for Michael Collins, Neil Armstrong and Buzz Aldrin would not have made it back alive. At approximately 8 o'clock, the lunar module began its final descent to land on the moon. Then, at exactly 8:10, an alarm began blaring. A 12:01 alarm. Neither Neil Armstrong nor Buzz Aldrin understood what this alarm signified. They immediately contacted Mission Control and asked what action they should take.
1201, roger, 1201 alarm.
The response from Mission Control is, ignore it. Proceed with the landing. It was later understood that the 12:02 was a cautionary alert. The Apollo guidance computer was overloading its processing capacity. Fortunately, the computer had been engineered to prioritize the most essential programs that were vital for the mission's success, even while operating under an excessive load. The computer contained an automated landing program designed to pilot the lunar module away from the moon's surface if necessary. However, at an altitude of roughly 150 meters, Neil Armstrong assumes manual control of the lunar module. He observes that the craft was headed for a landing site, populated with very large boulders. He alters the landing location, selecting a new spot approximately 4 minutes of flight time from the intended target. At 8:16, Buzz Aldrin checks the fuel gauge. Only 5% of the fuel remains. Seeing such a critically low fuel level, Mission Control initiates an urgent verbal countdown. This countdown would determine whether to complete the landing or to abort the mission entirely.
And we're critical fuel state, and that's why the 60-second call was given, and then the 30-second call.
Finally, at the very last moment, with only 30 seconds remaining in this countdown, Neil Armstrong transmits a radio message to Earth. The Eagle has landed. Neil Armstrong then prepares his spacesuit, opens the hatch, and takes his historic first step. This pivotal moment was witnessed live by 650 million people watching on television. His first words were heard across the globe. Following him, Buzz Aldrin also steps onto the lunar surface, and for the subsequent 2.5 hours, they gather samples of lunar soil and rocks, take numerous photographs, and deploy a variety of scientific instruments. While it is accurate that the Cold War was a significant motivator for the moon landing itself, the fact that a lunar landing was being attempted, such a monumental achievement, meant that scientific instruments were naturally included. Numerous scientific objectives were also integral to this mission. For instance, a television camera was set up on the moon to broadcast signals back to the Earth. They also brought a device to measure the solar wind reaching the lunar surface. Another instrument was deployed so that laser beams could be reflected back to Earth, allowing scientists to measure the precise distance between the Earth and the moon. Additionally, a passive seismometer was installed to measure seismic activity, or tremors, occurring on the moon, though they are not called earthquakes, but moonquakes. In total, they collected a 23-kilogram sample of rocks and soil from the moon. They also placed an American flag and a plaque inscribed with the words, "Here men from the planet Earth first set foot upon the moon."